Today we're going to talk about the fuel system in the 1999 Grand Cherokee. You can pause and read the operation of the fuel injectors. They are electrical solenoids. The injectors are electrically energized individually in a sequential order by the PCM. The PCM will adjust the injector pulse width by switching the ground path to each individual injector on and off. Also, during the startup, the battery voltage is supplied to the injector through the ASD relay. Here you can see the operation for the fuel pressure regulator. It is used for fuel pressure, fuel return, and fuel supply. If the fuel pressure at the pressure regulator exceeds approximately 49 psi, an internal diagram closes. Excessive fuel is then routed into the separate fuel return line and returned to the fuel tank through the top of the fuel pump module. Here you can see the PCM schematic, and the bottom left you see the battery. Next you can see the automatic shutdown relay, the fuel pump relay, and the fuel pump fuse. The PCM is in the center, and the injectors are on the right, which are being powered by the PCM. Here we have our ASD relay, our fuel pump relay, our injector fuse, our fuel pump fuse, and our ASD fuse as well. That's all you can see from here in the fuse box. Here we have our fuel injectors. It has 2 wires, each one of them, as you can see. And we have 4 on this side and 4 on the other side. Here's the wiring diagram. As you can see, it goes from C102, which should be fuse 26 for its power. And here in the fuse box, as you can see, fuse 26 should be this one. Here we're doing an ohm test on the injectors. What we should be reading is 12.2 ohms depending on the temperature, 68 Fahrenheit. We are reading 12.3 ohms and 12.4 and fluctuating just slightly. Here we're going to read our voltage drop across our injector, and we are reading 0.3 to 0.5 volts. Here's another voltage reading, and it's reading 0.4 to 0.6 volts, and it fluctuates. Now we're gonna get our voltage drop with high RPM. Now we're gonna measure the voltage drop with a rich engine. When we injected propane into the system, the volts dropped to millivolts. As you see here, as the engine started, you can see a high RPM, and as well as the injection milliseconds goes up, and cylinder 1, cycle 1, cycle 2, cycle 3 as well. As you can see here, our RPM goes up and down, as well as our injection milliseconds. It spikes up and spikes down. Our ignition cycle 1, 2, and 3 is consistent. Our map sensor is spiked down. It's an average of 1.3 volts. AUT, upstream O2, purge duty cycle, target IAC steps, engine RPM, and fuel allowed, yes, and then fuel pump relay is on. I'm gonna increase RPM here, and we'll see our injection. Our fuel injection milliseconds go up. As you can see, our milliseconds, you see there's a constant right there. That's because we put some propane into the system.
Okay, here is our oscilloscope readings from the Jeep. here we do a little bit of revs, and then now we start feeding propane into it. And you can watch here as we stop feeding propane in, the engine hangs the injectors open at the end because it is used to the rich running condition for some reason, and it tries to continue that. I believe would be the only thing that made sense to me. So we did some work diagnosing a low fuel pressure condition on my 2007 Dodge Ram 2500 with the 6.7 liter Cummins engine. My truck uses a Bosch high pressure common rail system, and the main components of the system are the lift pump, the fuel pump or gear pump, the high pressure fuel pump for the injection, the common rail itself, and then the injectors. Some more parts of the system, more major pieces, are the fuel filter and water separator, other various fuel lines, the sending unit, the pressure limiting valve, the overflow valves, and the accelerator pedal position sensor. The fuel injection pump supplies high pressure fuel to the rail independent of engine speed. The high pressure fuel accumulates in the rail and is available for whenever the injectors require it. The ECM controls fueling and timing of the injectors. Fuel goes in through the lift pump. It comes from the fuel tank, and it feeds the fuel pump or gear pump, which is a part of the injection pump. Fuel from that is fed into the high pressure fuel pump, where it can reach pressures in between 3,000 to 26,000. The pressures that the high pressure pump creates are controlled by the FCA, which is an electronically controlled solenoid valve, and it determines how much fuel goes into the injection system and how much fuel goes into lubricating the pump and then into the return system. There's also an overflow valve, which regulates how much excess fuel is used in the pump.
Okay, I did a data log on my truck and made it set the low fuel pressure codes that we were trying to diagnose. And this is our data for when the codes were set. As you can see, we are building, this is our actual rail pressure, this is commanded, this is our duty cycle for our fuel control actuator valve. And as you can see, as we go along here, we're good fuel pressure, and then it drops right there. See? In that one PID screen. So in that area, we have our rail pressure drop by about 3,000 psi, and our duty cycle drops by 1%. And then as we continue going over, we see our fuel pressure drops again and our duty cycle drops 3%. And now we're commanding even more pressure, which is correct, as the lower the duty cycle, the higher pressure commanded. And as we continue, we can see that we just continue dropping rail pressure here, raising duty cycle and raising commanded fuel pressure, and that is consistent as we continue across. And our deviation actually ends up being around 1,400 psi worth of fuel pressure. And you can see it's fighting to get the fuel pressure back, but it is stuck down at around 11,000, and that's our max deviation there pretty much. We're going from 25,000 psi down to 11,600, and we are maxing out our duty cycle control, trying to fight that. Conditions that might cause this could be a leak in the fuel system or potentially a stuck injector that could be causing this. Okay, so as you can see, whenever I lift here, you can see as I lift, our commanded pressure drops and then our actual pressure spikes, which makes sense as there's leftover fuel pressure and the engine doesn't know what to do with it. But as you can see, we are capable of making well over 20,000 psi. It's just, it will not hold it for some reason. This is a zoomed out view of our graphs, but as you can see, this is not just because of the codes. These are two other high throttle points or high pressure points. And as you can see, the PCM here is still commanding around 35,000 psi, like it's at the top range, and we are still losing it right there, and our duty cycle is still jumping, trying to make adjustments to save our rail pressure, which this is all potential signs of a sticking injector not allowing the rail to build the pressure that it is commanding. Okay, we are going to be doing a wide open throttle test and then immediately letting go of the throttle to see injector hang. Here we go. And as you can see, it hangs a little bit from 3,600 to about 3,300, and then again at around 2,200 down to idle, which could indicate an injector hanging. We're going to run some injector treatment through the truck and see if that improves anything.